So you are going to, somebody remind me to turn that off to this. That is another problem. All right. Of course, the SOHCAHTOA comes into place. What does that even mean?
Different side,
Okay. So you've got, this is the very background. Sine of, theta is the opposite over the hypotenuse. That's what the O and the H stand for. It's not Ohio State. All right. If this is your theta, this is your opposite side of theta, and this is your hypotenuse. Okay. And of course, CAH sine stands for what? Cosine equals adjacent over hypotenuse, and then tangent equals opposite over adjacent. Okay. It's not really going to come up a bunch, but that's the basis of all the unit circle business, which is going to come up a bunch. So some of our trig identities get fundamental. We already had one come up today. That was the one Maggie used right over here on number 10. Okay. Sine squared plus cosine squared equals 1. Now, there is 2 that are derived from that. If we take and divide by sine squared, what is the new function that we get? 1 plus cosine over sine is cotangent squared equals what's 1 over sine? Cosecant squared. So that's one function. Okay. That might come up. These are the ones that I know you had a page of them that you were like, okay, here's your, list of identities, but those were not on the page. This is the page that you're supposed to, this is the piece that you're supposed to know. If I divide by cosine squared, then I get, what's this? Tangent squared plus 1 equals secant squared. So those are your 3, I guess they call those Pythagorean identities because they come from when you're doing the unit circle, any value has an x and a y, but we don't call it an x and a y when we're doing trig. What do we call them? In what order, though? Cosine sine. Okay. And we usually do theta, not x, just because x gets confused with the word pair and blah, blah, blah. So that's when you take the unit circle. I'm getting ahead of myself here. I'm getting ahead of myself, but I got to keep going here. Unit circle means on this circle of radius 1 unit, okay? Every value here, and we're going to focus on a couple of them in here, has a value that we're supposed to remember, okay? And they come from, if you look at, let's just take a look at this 45, 45, right here, okay? So, really that's how many degrees. If it's a 45, it's really how many pi over 4, okay? Because pi is 180 degrees, and 180 divided by 4 is 45. You should know that we have multiples of 30, 45, and 60 that we will all know, okay? We will know all these, or we can figure them out, okay? And that's really pi over 6, pi over 4, and pi over 3, That's how they fit there, okay? Now, I don't know, again, your background as far as like how much of that stuff I remember. Did somebody give me a unit circle and then I just fill it all out and I use it for that test? I don't know, but that is not probably what we're going to want to do in calculus because we're going to want one value. Okay? We'll come back to some of those fundamental, but we already used some of them, so let's just go be clear. What sine or cosine? And cosine over time, cosine over sine, cotangent, 1 over sine, cosecant, 1 over cosine, secant, 1 over tangent, cotangent, okay? And then we can go on, 1 over cotangent is tangent. I mean, we're just not going there. Those are some that, you know, fundamental means they're, you know, something that we're supposed to know. Now, if you don't know and you're like, wow, we didn't really go there, I could tell you I'm surprised, but, you know, it happens. You just now have to go there, okay? Probably one other one that I would be expected you to remember would be the sine of 2x. Who remembers that one? 2 sine of x, cosine of x. And cosine of 2x, that didn't really come up very much. Okay. Yeah, but they're all equivalent just because we're substituting this guy in there somehow, okay? Honestly, sine of 2x usually comes up way more than cosine of 2x. I don't know why. So if you're like, okay, I can only do so much, then grab sine of 2x. The rest of them should probably be part of your long-term memory at this point. Maybe not the red and the blue over there because you notice that I got those from the black one. But anyway, going back to what we call the Pythagorean theorem, remember this is really x. It's also cosine. This is really y. It's also sine on the unit circle, okay, because the radius is always 1. So cosine squared plus sine squared is the same as 1 squared. That's the Pythagorean theorem. That's what they call the Pythagorean identities. If you want to remember that, I'll come back. Okay. Anyway, let's talk about the unit circle because I know that there's different expectations for where you come to calculus with. So let me scoot this all over here. All right. First of all, who remembers what that stands for? Maggie. All students, it's an acronym, take calculus, which is a lie, but calculus teachers want to believe that it's true. All right. Now, if you don't remember, if you've never heard of, who has never heard of that acronym? Okay. You haven't heard of that acronym. That just means that you did the unit circle a little bit differently than maybe I'll just say you should have. Just because I'm the expert. I'm really kidding. Okay. So this is an acronym that tells you which functions are what? Positive as opposed to negative in what quadrants? Okay? Now some of you will do minus plus, plus minus, plus minus. Is that what you all kind of did when you figured out what your signs were as in SIGN? Okay? Went to an AP workshop one time and this lady was, as opposed to keeping SIN different from SIGN, she called it SIGN. It just like went through me every time. I was like, stop it. But I get it because you have to spell it if you don't want to. I misunderstood SIN with SIGN. SIGN, yeah. I know. It was like, but anyway, okay. So we're going to use the symmetry involved in these quadrants. Okay? If we say A stands for all are positive. Okay? Sine is positive. Cosine is positive. Tangent is positive. And of course, their reciprocals are positive. Okay? Because when you flip around reciprocal, the SIGN stays the same. Second. All right, so those are all plus. That's what A stands for. All of them are plus. Okay, positive. All right, S stands for sine is positive. Okay? That means, what do we know about cosine and tangent? They're negative, okay? T stands for tangent is positive. That means sine and cosine are negative. C stands for cosine. Cosine is positive. That means sine and tangent are negative. Okay, so that's all that means. How is that helpful? Well, it's helpful because we know that this little guy right here in the second quadrant is the same value, has the same values as this little guy right here, except for the SIGNs. Okay? So we are going to take and memorize, if we haven't, the 3 that we need to know in each quadrant. Okay? Now there's a system to this if you haven't memorized it. Okay, first of all, what is the little one? Pi over 6. Okay. I'll write this with a different color. Pi over 6. The middle one is, and, okay. Again, that's 30, 45, and 60. Okay? We'll do a little bit of both, but primarily it's in radians as in terms of pi. Okay. Now, let's remember we have for each, we have a cosine, sine. Cosine, sine, cosine, sine. And we have to remember that. There's a system. How do we remember it? Okay. We start up and we go up. So we do 1, 2, 3, and then the other one is the opposite. So 3, 2, 1. Okay? Start up and go up. All right? We divide everything by 2. And we take the square root of everything. Square root of 1 is still 1, so I'm not messing with those. So there we go. The cosine of pi over 3 is 1/2. The cosine of pi over 4 is radical 2 over 2. The sine of pi over 6 is 1/2. Okay? Now, if we're in a different quadrant, then we just have to go to this guy over here and say, all right, I know that, let's say we want the tangent of negative pi over 6. Okay? First of all, we have to figure out the quadrant, so we can draw it. What quadrant is it? Fourth quadrant. And tangent is what in the fourth quadrant? Negative, so we put the negative, then we say, all right, what is really the theta that we're after? It's either pi over 6, pi over 4, pi over 3. Of course, it's pi over 6. So we're going to grab tangent. Oh, wait, tangent is sine over cosine. So then we're going to take the sine, which is pi over 6, 1/2. Over radical 3 over 2, the 2's cancel, and we get 1 over radical 3, or radical 3 over 3, and yes, don't forget, we already talked about that being negative. Okay, the tangent's not probably 1, you probably should have started it, but anyway. Okay, so it's a process, but it's not like, here, let me take at least 10 minutes to complete my unit circle, and then I have that reference for the only time I'll ever need it in this problem. Okay? All right, so let's take a look. We got, so that's those 3. Now, we spent days developing that, so that wasn't like, oh, remember those. It was a big deal, okay? But that's the grand plan, is that these 3 guys are in these 3 over here, and then all we have to do is change the SIGN according to this guy right here. Okay, what if it's on a quadrant? For example, what if it's pi over 2? And I want to know the sine of pi over 2.
1.
And how do I know that? You're on the 0, 1, right? That's my sine, so that equals 1. All right, what's the coordinates of that point? 1, 0. So what do we know here as far as cosine of 0? It would be 1. What's the cosine if I go around and just stop at the same spot? Still 1. Okay. What about the sine of either of those? 0. Because it's, remember, cosine and sine. In that order, alphabetical, just like x and y is alphabetical when we were doing order pairs. Okay, what's the order pair for this guy? -1, 0. So the cosine of what is -1? Pi. That's 180 degrees. Okay. Over here, what's the ordered pair? 0, -1. So tell me what. Let me get this. Let's say we have the sine of what is -1? 3 pi over 2. What else? -pi/2. You know, whatever. Okay. So those quadrant angles are real easy to do. All you need to know is what the ordered pairs are. The first one is the cosine. The second one is the sine. You can go negative angles. You go around, what's that, clockwise or counterclockwise? Okay. And then go positive. So we go positive angles go this way, negative angles go this way. But they land where they land, and you have to figure out either if they're on a quadrant or if they're in a quadrant, what their signs are. Okay? So that's the unit circle. Let's try this next page. Okay. All right. You want to try those? Do I want to get you started? I can do it. You can do it. Okay. I think they're all pretty, they're not even really very hard, but again, it depends on where you're starting from. Go ahead and try them, and go walk around. Okay. And you shouldn't have to draw the whole unit circle together. Okay. Rusty. I know we're all, at least it's rusty. It's not like, I've never had to do before. But yeah, you're just not used to the right. But you developed it and you knew what it was. It was like, okay, I have it memorized now, just give it to me. Yeah, I get that. That's just a different level. So the twos are always going to cancel out. So if you want to keep that in mind. So it's just, well, no, it's 1 over that. The twos are going to cancel out, right? So that would give you, because you're going to multiply 2, they're going to cancel out. So you get 1 over, and it goes for you, right? They always write that. All right, how are we doing here? And what was your, you all did it? It's not like from here on out, all we're going to do is trade. So it's just that whenever it comes up, we got to figure out what we got to do. I'm thriving. She's got PTSD. My friend, I'm just funny. I know. You make it? Okay. So you're in the same. Okay. So you're good. It's just a little different. Yes. This is approaches. This is the same. No. But it's a little bit. Yeah. Yeah. It's definitely, I mean, we're not going to go back to to how we got all those values, we're just going to say how you remember them. Just because that's pretty common. We're not in Kansas anymore.
I can't read your light blue,
Right?
I'm not going to use it. You don't even eat more carrot. It hurts. Carrots actually don't help your eyesight. That's a myth. So funny. I didn't go more. Less. Do you trust me? Because actually I took it out. I couldn't put I just myself. I that's not anything except
Do what? Okay, you done? Yeah. All right, that's good. Lana, you finished? Okay. Finished? All right, let's distract you. All right. On, you good? All right, let's check it out here in a minute. How what? That's kind of funny. And there's liquid. Oh no, it's not one of those. Okay. That's all right. Yes. All right, let's go here, everybody. Okay, here's the starting point. This is in the middle of a problem. So you say, all right, I can't really remember them, so I need like a little cheat sheet. So here I go. All I need is the middle one, but I'm going to do the whole page, so I'm going to complete this. So I do 1, 2, 3. All right. I don't have to do this in this order, but all right. So those are your cosine sine values in that order. And you might want to also, if you're new at this, remind yourself that this is pi over 6 because the 6 thinks it's a bigger one, and pi over 3 is really the bigger one, right? 180 divided by 3 is 60, and 180 divided by 6 is 30. So, all right, so this is your reference, and this is all your drawing. And as we need to fill in the quadrants, we will. But we're not going to do that if we don't have to. Okay, so 45 degrees is really pi over 4. So the tangent is radical 2 over radical 2, which is what? Done. Okay? Now, no one will beat you up if you do this and then do what? That is not a problem. But most of us, or I shouldn't even say most, 9 of us today probably knew that was 1, right? Okay. So sine of pi over 6. Okay, pi over 6 is right here. Sine is what? 1/2, right? That's right on the chart that you filled out. If you filled that out wrong, guess what? You are screwed. All right. Okay, cosine of pi over 2. We don't have that because that's a quadrantal angle. So cosine pi over 2 is right here. So what's the ordered pair there? 0, 1. So the cosine is the first one, which is 0. Okay? Tangent of pi, we don't have that one either. That's over here. What are the ordered pair? -1, 0. So the tangent is 0 over -1, which is 0. Remember, it's sine over cosine for tangent. Okay, cosine of negative pi over 6. Okay, now, negative pi over 6 is in what quadrant? 40. We already talked about that one a little bit. All right, so we're going to use the cosine value, which is radical 3 over 2. And then we're going to say, oh, wait, all students take calculus. Cosine is positive. We're good. Okay, so 1, 2, 3, 4, 5. Who's 5 for 5 here? Awesome, good job. Okay, 60. 60 is really pi over 3. So sine of 60, pi over 3, radical 3 over 2. Okay, we're in the first quadrant. We don't have to worry about the SIGN. Okay, what's the matter? That's a humongous slide. I know, it looked like it was all right, 3 pi over 2. Right here, what's over here? 0, -1. So cosine is first one, which is 0. Okay. Tangent pi over 3. Radical 3 over 1. Right? Radical 3 over 1, which is radical 3. It's in the first quadrant. We don't have to go there. Okay? Many times it's going to be in the first quadrant or the fourth quadrant or the second, depending on, where we are. But if you get the essential first quadrant and maybe the adjacent quadrants, rarely is it over in the third quadrant, but, it is what it is. So on this test that's coming up that we should be having Wednesday, but we're not in school Wednesday, is I'm going to have a little section that I'm just going to ask you these guys right here. Yeah. Just because I want you to know those and I want you to be aware that that's important. Now, it may be, here it comes again, it may be like, beyond that, it may be 2 questions on the whole test that I need to know this trig. But if you don't know the trig, there's 2 questions you can't do. So, all right. Okay, I think we are, wait, does anybody have any questions about the unit circle, just in general? Okay, you kind of know where you stand with that. Let's go beyond here, and we have a couple. I know we need to finish that problem. Okay, so we got to the slope of the tangent. And if you recall, this is the only time I said m of slope. Otherwise, I just started with f prime because that's what I'm doing. I wanted to remind myself that that's what I'm looking for. Okay. Okay. So now I have I'm just going to erase this because I don't really need it anymore. I'm going to plug in pi over 4. So here we go. 4 cosine squared of pi over 4 minus 4 of sine squared of pi over 4. Okay. Now, again, we need some values. In your head, you're doing boom, boom, boom. Pi over 4 is the middle, so 1, 2. All right, so this is radical 2 over 2. Okay? That's all you're doing for that problem if you need to. Some of us are over that. We did that last year. Now we're done, but you got to do what you got to do. All right. So what does this mean? Cosine squared of pi over 4. I'm really confused. What does that even mean? Abby? That's right. It really means this. Good job. Okay. And what is the cosine of pi over 4? Square root of 2 over 2, and I need to square just that value. Okay, and this means the sine of pi over 4 squared. We write it like this, but you got to remember that's what it really means, so be careful. What's the sine of pi over 4? Okay, now I'm going to be kind of efficient and say, I'm subtracting exactly what I got. Am I really going to do the math? Because I know I'm going to get 0. So the slope is 0. Okay, so go over and to your calculator and put in your f of x. Just so we can see this. Yeah.
Cosine squared x minus sine squared x is cosine 2x.
Just that would be 4 times cosine 2. Thanks. If you want to use the formula, yeah. Are we still what? Yeah. Nah. All right. Yeah. Yeah. At this point, your zeta is just a variable, so yeah, you have to use x. What's happening now? All right. Okay, now this one we can kind of eyeball because it's 0. Oops, dang it. Where's my, yeah. There's my calculator. Here we go. Okay, so what was it? 4 sine of x. Okay, make sure you close your parentheses that calculator gives you, and then cosine of x, close your parentheses. Just a good practice, okay? Make sure also whenever you're doing trade, what's my mode in? Radians. Radians is right here next to degree. If you ever loan out your calculator to a pre-cal students, they're going to turn it back. Or how about at the ACT, you have all your, for the ACT, they're probably going to do degree. So it's really a good idea to just kind of be obsessive about changing. When you're doing trade, you gotta have radians. That's what the calculator expects and wants. Okay, so we got that. Your window, I got negative pi to pi. That probably will work. All right, now, if you don't know the scale, we are looking for pi over 4. Let me just make my scale pi over 4. And that way the first tick mark is over 4. The first tick mark you see is going to be pi over 4. And you see that clearly this has a 0 slope. And that's what we were at. That's what we just did here. Okay? That's where we did it. So it's nice to give yourself a visual. I know sometimes you're just like, I just don't intend to do that. I gotta go for, I'm just good. Hopefully it's right. If you have an even problem here on test and you were doing that, you know, you could check that out. But probably wouldn't have a calculator for this problem anyways. All right, so let's try a couple more that require some unit circle values. Let's do Maggie's 10 over here since it's handy. We won't do it again, but this was the original problem. Okay, and we figured out y prime to be this. We won't do it again. X plus cosine of x squared. All right, and let's find the equation of the normal line at x equals, I just want to make sure I don't have any values that are wrong, 0. Okay.